Hello students, myself Purva Joshi, Assistant Professor at IT Institute of Engineering and Technology. Today we will discuss few more topics of partial derivatives. So let's begin with the first topic, that is chain rule. So if z is the function of u and u is the function of x and y. Okay, so let's make a tree diagram. Now here you can see z is the function of u variable, right? So we will write like this: z is a function of u and u is a function of x and y. So we will write in this form: u is a function of x and y. Okay, now here from z to u we have only one variable, right? So we will write t, and u is a function of two variables, so we will write del at both the sides. Okay, now the formula to find del z by del x is what? Firstly, here we have d, so we will write dz by du into, then we will write del u by del x. Okay, next one, del z by del y. Okay, so firstly here we have d, so we will write dz by du into del u by del y. Okay, next let's discuss total derivative. So if u is a function of xy, where x is a function of t and y is a function of t. Okay, so firstly we'll draw a tree diagram. So here here u is a function of x and y. So here we will write u is a function of x and y, and x is a function of t and y is also a function of t. So we will write it together here like this. Okay, now here we have two variables, so we will write del, and here we have one variable, so we will write d. Here also it will come d. Okay, now the formula to find du by dt. Okay, so firstly we'll go through this. So del u by del x into dx by dt. Next one, plus del u by del y dy by dt. So this formula we will write from this tree diagram. Okay, next, suppose if u is a function of three variables, that is x, y and z, and x is a function of t, y is also a function of t, and z is also a function of t. So firstly draw tree diagram. So here u is a function of x, y and z. Okay, x, y and z are function of t, so we will write like this. Now here we have more than one variable, so we will write del, and here we have single variable, so we will write d. Now in order to find du by dt, so what we will write? Del u by del x into dx by dt. This is the first portion. Okay, plus next del u by del y into dy by dt. Okay, plus from here del u by del z and dz by dt. Okay, so in this way you will write the formula using this diagram. Next, let's solve an example. If w is equals to xy plus z and x is equal to cos t, y is equal to sin t and z is equal to t, then find dw by dt. So firstly we'll draw a tree diagram. So here w is a function of what? X, y and z. So here we will write x, y and z. Again x, y and z are function of t. So here everywhere we will write here t. Now here we have three variable. Okay, so here we will write del, and here we have one variable, so we will write d. Okay, now what we have to find? dw by dt. Okay, so the formula will be del w by del x into dx by dt. Okay, from here del w by del x into dx by dt plus next one del w by del y into dy by dt. Okay, plus the third one from w to z. So we will write here del w by del z into dz by dt. Okay, solve this, that is del w by del x means derivative of w with respect to x. Okay, so we have to find derivative from this. we will keep here y and z constant. Okay, so derivative with respect to x, so derivative of x is 1, y is constant. So here we have answer y into dx by dt means derivative of x with respect to t. So answer is what? Minus sin t. Okay, plus next one del w by del y. Okay, so from here we have to take derivative with respect to y keeping x and z constant. So answer will be x. So here we will write x into dy by dt means derivative of y with respect to t. So it will come cos t. Okay, plus del w by del z means derivative of w with respect to z. X and y constant, so derivative of this term is 0 and derivative of z is 1. So here we will write down 1 into dz by dt. Okay, so derivative of z with respect to t, answer is 1. Now we have to simplify further. So in place of y we will write sin t and in place of x cos t from the question. So here you will get minus sin square t plus cos square t plus 1. Now we know this formula, cos square t minus sin square t is equal to cos 2t. So final answer of dw by dt is what? Cos 2t plus 1. Okay, next example. If z is equal to xy square plus x square y and x is equal to 80 square, y is equal to 280, then find dz by dt. So firstly we will draw tree diagram. So here z is a function of x and y. So here we will write z is a function of x and y. Then x and y are function of t. So we will write like this. Now here we have more than one variable, so we will write del, and here we have only one variable, so we will write d. Okay, so now the formula to find dz by dt is what? Del z by del x into dx by dt. Okay, this term plus del z by del y into dy by dt. So this term. Okay, so just we have to simplify it further. Now derivative of z with respect to x, so it is y square plus 2xy. Here we are keeping y constant. Okay, into derivative of x with respect to t. So from this you will get 280 plus del z by del y means derivative of z with respect to y keeping x constant. So from here you will get 2xy plus x square into dy by dt means derivative of y with respect to t. So from here you will get 2a. Okay, simplify it further and in place of x we have to write 80 square, in place of y 280, and simplify further to get the final answer of dz by dt is equal to 16a cube t cube plus 10a cube t raised to 4. Next one. Next example is for z is equal to tan inverse x upon y, x is equal to u cos v and y is equal to u sin v, evaluate del z by del u and del z by del v at the point 1.3 comma pi by 6. Okay, so firstly we'll draw this tree diagram. So here z is a function of x and y. From here you can see, so we will write z is a function of x and y. Later x is a function of uv and y is also a function of uv. So here we have written u comma v. Now everywhere we have more than one variable, so we will write del everywhere. Okay, now we have to find del z by del u. Okay, so firstly we'll move here from here, that is del z by del x into del x by del u, that is this first term, plus next one del z by del y into del y by del u. So this is our second term. Okay, next one, derivative of z with respect to x. So from here we have to take derivative of z with respect to x keeping y constant. Now we know the formula of tan inverse x, that is derivative of tan inverse x is 1 upon 1 plus x square. Okay, so using that formula here we will write 1 upon 1 plus x square upon y square into, we have to apply chain rule. Okay, and we have to keep y constant. So the answer of this derivative of x upon y will be 1 upon y. into del x by del u means derivative of x with respect to u keeping v constant. Okay, so answer will be cos v plus next one del z by del y, that is derivative of z with respect to y keeping x constant. So first term will be 1 upon 1 plus x square upon y square into chain rule. Okay, now here we are keeping x constant, so x as it is, and derivative of 1 upon y is minus 1 upon y square, and this, that is del y by del u means derivative of y with respect to u and v is constant. So here we have sin v. Okay, simplify this further and in place of x you have to write this u cos v, and in place of y u sin v, and simplify further. Okay, so you will get final answer as del z by del u is equal to 0. Next one. Now we have to find del z by del v. Okay, so this is our tree diagram. So the formula will be del z by del x into del x by del v plus next term, that is del z by del y into del y by del v. Okay, so this formula, now we have to simplify further. Okay, now we know z is what? Tan inverse x upon y. Okay, x is what? U cos v, and y is what? U sin v, right? Next one. So here you will get del z by del x as 1 upon x square plus y square. This we have understood in previous form, right? Next, we have to just simplify this. So del x by del v. So del x by del v is what? We have to take derivative with respect to v keeping u constant. So here you will have minus u sin v. This term will remain as it is, means we have solved before. Okay, next del y by del v means derivative of y with respect to v keeping u constant. Okay, so here you will get u cos v. Simplify this further and in place of x you have to write u cos v, in place of y you have to write u sin v, and you have to simplify it. So you will get answer as del z by del v is equal to minus 1. Okay, next one. If u is equals to f of x minus y in comma y minus z, z minus x, then prove that del u by del x plus del u by del y plus del u by del z is equal to 0. We have to prove this. So for that, what we will do, we'll suppose this x minus y as L, y minus z as m, and z minus x as n. Okay, so now here you will get u as a function of L, m, and n. And now we know L is a function of x, y, m function of y, z, z, and n is a function of zx. Okay, so we will draw a tree diagram in this way. So u is a function of L, m, and n. Okay, and L, m, n are function of x, y, and z. Okay, everywhere we have more than one variable, so we will write del everywhere. Now in order to find del u by del x, okay, so we have to find first del u by del x. So we will solve this, that is del u by del l into del l by del x plus del u by del m into del m by del x plus del u by del n into del n by del x. Okay, so we will apply that formula. Let's see. So del u by del x, as we have discussed, it is written here. Okay, now we know what is L. L is what? X minus y. M is what? Y minus z, and n is what? Z minus x. Okay, del u by del l as it is. Derivative of L with respect to x is what? 1 from this. Okay, then del u by del m as it is. Derivative of m with respect to x, and y and z are constant, so answer is 0. Next one, del u by del n as it is, and derivative of n with respect to x, so it will come minus 1 from this. Okay, here we will keep y and z as a constant. Simplify this, so you will get del u by del l minus del u by del n. Next we will find del u by del y. Okay, so here just a minor change in this formula. Here in place of x, here we have y. Okay, so now we have to take derivative with respect to y. So just take the derivative, this del u by del l, del u by del m, and del u by del n as it is, and the derivatives are written here, that is minus 1, 1, and 1, which we have taken with respect to y from these three. Okay, next simplify this, so you will get del u by del y equals to minus del u by del l plus del u by del n. Again we have to solve del u by del z using the same formula, right? Now here we have z everywhere, so we will take derivative of lm and n with respect to z. Okay, so taking the derivative and simplifying it, you will get del u by del z is equal to minus del u by del m plus del u by del n. Okay, now we have to add them, so adding 1, 2 and 3, you will get the answer of del u by del x plus del u by del y plus del u by del z equals to 0. Okay, next topic is implicit function. So any function of the type f of xy is equal to c, where y is a function of x and c is constant, is known as implicit function. Let's see example. Suppose x cube plus y cube is equal to 3xy. This is an example of implicit function. So now let's see the formula for implicit function. If f of xy is equal to c, where y is a function of x and c is constant, then dy by dx is equal to minus del f by del x upon del f by del y is equal to minus fx upon fy. This is also known as implicit differentiation. So the proof is, here we have f of xy is equal to c. Now total differential coefficient of f with respect to x is given by df by dx is equal to 0. Okay, so the formula for this is what? Del f by del x into dx by dx plus del f by del y into dy by dx is equal to 0. Okay, now we will make this dy by dx as a subject, so you will get here minus del f by del x upon del f by del y. We know del f by del x means what? Fx, and del f by del y means what? Fy. So the formula for dy by dx is what? Minus fx upon fy. Let's solve one example. If x cube plus y cube is equal to 3axy is given, we have to find dy by dx. Okay, so the solution is, function is given x cube plus y cube, take this 3axy left side. Okay, so you will get minus 3axy. Okay, now let's find fx, that is del f by del x means derivative of f with respect to x, keeping y constant, so this term is 0. From here we have 3x square minus 3ay. Okay, next one, fy, that is derivative of f with respect to y, keeping x constant, so you will get derivative as 3y square minus 3x. Okay, now the formula for implicit function is what? Dy by dx is equal to minus fx upon fy is equal to answer of this del f by del x, that is 3x square minus 3y. Just substitute both the answer, so you will get the final answer by taking 3 common and cancel out. So the dy by dx answer is, and bring this minus inside, so final answer for dy by dx is equal to ay minus x square upon y square minus ax. Next example, if cos x raised to y is equal to sin y raised to x, find dy by dx. Okay, so let's begin with the solution. This is given in the question. So to solve, we will apply log on both the sides. So on applying log on both the sides, we will get y log cos x is equal to x log sin y. Here we have applied the formula of log a raised to n, that is n log a. Okay, now the function fxy is equal to, bring this x log sin y on the left side, so you will get y log cos x minus x log sin y. Now we will find fx. Okay, that is derivative of f with respect to x, keeping y constant, so y is constant, so as it is, derivative of log cos x is what? 1 upon cos x into derivative of this cos x, that is minus sin x, minus derivative of x is 1 and log sin y is constant. Simplify, so here you will get minus y 10x minus log sin y. Okay, next we will find fy. So derivative of f with respect to y, keeping x constant. So from here x we will keep constant, so log cos x as it is, derivative of y is 1 minus here x as it is, derivative of log sin y is what? 1 upon sin y into derivative of sin y, that is cos y. Simplify this, so you will get log cos x minus x cot y. Okay, Now apply this formula. Dy by dx is equal to minus fx upon fy. Substitute both the answer and this multiply this minus inside, so you will get final answer of dy by dx. Okay. So I hope you have understood in this session. Thank you for watching.